Good. I think we can get started. Super. On behalf of Anchor, I'd like to say thank you to all of you for taking the time to join us here today to hear more about best practices in data cleaning and curation. By way of introduction, my name is Nikolai. I'm the product manager here at Anchor, and I'm joined here today by my colleague, Alex, who is our ML solutions lead. The agenda for today is tightly packed. First off, we'll briefly discuss why data quality matters, especially in the context of computer vision. Next, we'll share our learnings with you from working with computer vision teams on their cleaning and curation practices over the years. We'll mainly focus on old school predictive AI today. However, the majority of learnings apply just the same for generative AI. Based on our conversations with these teams, we'll share a 6-step process we've developed internally for operationalizing your data cleaning and curation processes. Afterwards, Alex will take you into a live demo to show you how to implement these 6 steps to improve your data quality. In the end, we'll take a Q&A covering both the pre-submitted questions and anything that pops up during the webinar. So please feel free to use the Q&A field to write any questions along the way, and we'll get to them in the end. Good. Machine learning and AI has been on a wild ride. And I think many of us here feel honored and excited to have been part of it so far. The academic research is released almost every week, and we don't get to go a month without a new foundation model, be it a large language model or large visual model. At the same time, consumer applications like ChatGPT and Tesla's Autopilot are suddenly seeing mainstream adoption, while this year's CES gave us a sneak peek at the sheer number of AI-assisted consumer products that's about to hit the market. For us here at Anchor, it seems like the future of AI is now, but with more advanced technology, customer requirements, and problems to solve, the need for smarter techniques to handle data has never been more urgent. But not just any data. Even though we see all of these flashy models and prototypes at CES, powerful foundation models from big tech companies, the reality is that somewhere between 80 and 90% of all AI models does not reach a production environment and bring actual value to customers. And this leaves billions of dollars in unlocked value on the table. As customer requirements and expectations to AI models increases, so does the demands for new models and new solutions. The recent rebranding from machine learning to AI might have led to an inflow of talent, capital, and attention. But at the end of the day, many of us are still spending our day-to-day trying to solve hard and non-sexy problems that require complex predictive models and does not involve any of these new emergent human-like behaviors that some of the language models does. Secondly, we've seen the European Commission take steps towards rectifying the new EU AI Act. If things play out similar to the GDPR here in Europe, we could very well see EU regulations be enforced as global standards across the globe. One such example that I think few of us has missed is this quote listed here, that training, validation, and testing datasets shall be relevant, representative, free of error, and complete. That's one of a mouthful. But as we all know, real-world data is rarely ever free and rarely complete. I mean, even the best-in-class open source datasets, such as Coco or ImageNet, is not ever free. But it also remains unclear what is meant by this word complete. So the specific rules of how models should be validated are missing, but one thing is universally true and will universally matter in the future. Its data quality will be front and center for all of us in the coming years. With that laid out, let's get into it. Here at Anchor, we're all about the data. And as such, we've delved into many conversations with computer vision teams over the past years to uncover what pain points they're facing on their journey to improve their data creation and data quality efforts. We'll first dive into the net negative trends and common errors before talking about some of the emerging positive trends that we see in the market. But let's first put things into perspective. On this flowchart, we can see what computer vision data pipelines used to look like. You had data collection, you had your storage, annotation, model training, model evaluation, and lastly, model deployment. Back then, computer vision teams was quite often niche projects undertaken by a single data scientist, single researcher, maybe a machine learning engineer, and potentially a company where there was a small team. The data scientist was responsible for all the steps, single-handedly handling the data, the annotation, the model training, and the deployment. And in these early days, the requirements were low, data volumes were small, and model capabilities limited. However, as computer vision projects increased in scope and AI rose in popularity, multiple stakeholders got involved. Now it's not only the data science team, but also data ops, the newly invented ML ops, and often multiple layers of management. This new complexity, combined with increased ambitions and project scopes, brought with it the need for new tools and new processes. From cleaning and curation to orchestration, versioning, and monitoring, the interconnected web of processes and tools has grown rapidly to cater to this increased complexity. And at the same time, we've seen data volumes increase drastically, which further affects the complexity level and the requirements for scalable and audible infrastructure. Today, however, we'll focus on how to conduct data cleaning and curation to manage, structure, and reduce the size of your datasets. We promise, though, that we will get to these other tools and processes at future webinars later this year. Just as a quick refresher here to begin with, to make sure we're on the same page, when we say cleaning, we refer to the process of finding and mitigating errors and inconsistencies in your visual data. So in other words, it's about removing the noisy, corrupt, and out of distribution data that you have, handling image duplicates, image videos, and so on, and standardizing and pre-processing the data. For curation, we refer to the organization and management of your data in the preparation phase for labeling, evaluation, and model training. This might include the data selection process. Here you could use various models as the techniques that we'll get on later, pre-labeling and enrichment with foundation models and other smart methods, and ensuring that your data is error-free, high quality, and sufficiently labeled. Most teams we encounter and work with are conducting this cleaning and curation in some form. And one question that we always like to ask is, what stops you from scaling from POC to real-world applications and production? So let's dive into some of these learnings that are relevant for the cleaning and curation phase. The first trend that we observed is that there is a high focus currently on quantity over quality. Here we found that there's a lot of overemphasis on the quantity and a lack of methods to clean visual data. And this has led to a lot of data sets with noisy, corrupt, and unwanted samples in them. There seems to be a tendency of data storages slowly transforming into landfills. Here, many of you told us that extracting the relevant data from these data storages, either data for labeling or training, is often hard and time consuming. And we used the data as often noisy, insufficiently labeled, and potentially of low quality. The second trend is related to the increase in the number of participants in this process, especially at larger corporations, that causes some level of siloed teams across the organization. As this disconnect between the different teams arise, there are different expectations from the team members to the model performance, the compliance, data management, and as such, collaboration can quickly deviate. And especially if your model objectives change along the way, this might require an update for your annotation instructions and your data curation guidelines. And if these are not aligned, it can very quickly be expensive and lead to errors if you have to redo the entire process. Last trend is around tooling. Many teams have adopted cloud storage already, premium annotation tools, and model serving infrastructure. So these were the early tools that was needed from the beginning. But for many of the new emergent processes, people are still mainly using Jupyter notebooks, Streamlit build tools, and tedious manual labor. And this works when you have a team size of a few people. But once you've gathered a full cross-functional team across the entire organization and are ready to scale, you will face serious growing pains as you try to scale the infrastructure as well. More practically, a few of these cleaning and curation techniques kept coming up, so just quickly mentioning them. First one is manual inspection of images and frames. Probably a lot of you that has tried to go and sample a video where you had to look through the entire video and manually select the frames that you wanted to annotate or train your model on. Secondly is one-off scripts, both in Python and Jupyter Notebook, to either analyze the distribution of your data and classes and conduct various ad hoc data analysis. And then lastly, using immature open source tools or home-built Streamlined apps, which again are helpful for creating POCs, but insufficient for scale, advanced processes, and automation. Some of the common problems that surface when the process is not structured are some of the ones you see here on the screen. So duplicate samples, which can skew your training data and impact the training of your models, leading to overfitting down the line. Similarly, corrupt data can have a big impact on our models. Noise in the data can obscure underlying patterns, making it difficult for our AI models to learn effectively in our respective domain and use case. And lastly, data outliers, which in some ways is a highly debated topic, because there's some opinions that outliers represent either valuable edge cases or they can be misleading anomalies, something Alex will also come in on later. For curation mistakes, we often see teams are using a completely random selection method for their labeling work and are not prioritizing their tasks in any way, which can be both costly and can lead to errors down the road when you've decided to label data that are not relevant at all for your specific problem at hand. Moreover, rarely do teams conduct any pre-labeling of the data, and if it's done right, you could end up saving 20 to 50% of the entire annotation time for the team, which would then trickle down to the annotation cost. And lastly, once the data has been labeled, it rarely passes through a full validation or review pipeline. And this last one is very important because without a proper label validation pipeline, you could end up with missing labels in your training data, which would lead to gaps in your model fitting the data, and inconsistencies and wrong labels that can lead to unreliable model outputs and models that often get confused. Ultimately, all of these problems, they impact our business's goals and outcomes. Of course, firstly, there's delayed time to market if we have to redo certain parts of the process. There's increased annotation and machine learning ops costs because we have to label more data than we actually need. And then lastly, there's poor model quality. If we train our models on bad data, we will get bad quality models. All of these factors are affected by the preparation phase and can be improved by conducting a thorough cleaning and curation process. So to give a concrete example of our company we work with has embraced this new cleaning and curation effort, I highly recommend to check out this case study with Automotive afterwards that we will share to all the panelists. Automotive's first cleaned their data after they curated it prior to labeling. They measured model performance at each stage, and this led to a 35% smaller training data set, which increased the MAP score on their validation set by 20%. More specifically, the automotive team found that their model performance degraded due to uninformative and bad samples in their training data. They uncovered that more than 5% of the data contained duplicates, corrupt images, and other irrelevant data points that plagued the dataset. So after the cleaning, they were still left with a vast amount of footage, and they had no way of prioritizing which video footage to label. Here they used a diversity acquisition function that Alex will also show later, where they curated the remaining clean data, and ultimately they ended up saving 33% of their labeling budget by reducing the dataset size, a critical component for the automotive team as they look to scale their labeling and model efforts going forward. So how can we distill these learnings and trends together into something that's more actionable and repeatable for you guys? At Ancord, we've defined a best practice 6-step process. This process will, of course, differ on a case-by-case basis, depending on your use case, your modality, or your data volume. But let's dive into it here. So assuming you've collected your data and hosted in a secure cloud environment, be a S3 Azure, or GCP, the first step is data cleaning. This step is, of course, taken to ensure you have high-quality data and removed all of the questionable samples we mentioned before. This is followed by a curation step to create a balanced and diverse data set, which is prepared for labeling. Next, before we send it to labeling, we'll enrich and pre-label the data. Depending on whether you're doing an image classification or an object detection, there are different methods that will vary, something we'll also come in on later. Hereafter, the data is prioritized for labeling. So you can imagine a case where you've curated 1 million images of frames, but you only have the budget to label the first 100,000 or 200,000. So in that case, you want to prioritize 10 to 20% of your data based on either a model-assisted approach or other smart methods instead of doing random sampling. Next, you annotate the data, either with your own internal team or an external annotation partner, whereafter you analyze the label data to ensure it's error-free and meet your own quality standards. As seen above the flow here, there are various teams that are engaged along the way, so it's important to ensure clear and streamlined communication as this project progresses from end to end. For today's demo, Alex will be showing the first 4 parts. We'll be showing some of the other ones later down the road. The main things I want to mention before I hand over to Alex is some of the concepts that we'll be showing. So for some of you that are new to Uncode and new to data-centric AI, when we talk about quality metrics, it refers to any image property that we can extract either from the image itself or the crop of the object, so the bounding box or the segmentation. This could be brightness, contrast, blurriness, or any other things that your imagination can think about. In our case, we automatically calculate 40 of those, so you can focus on what's important. You can also analyze your data set more holistically with these metrics, combining them with various visualizations and plots. Secondly, embeddings. Most of you are probably familiar with model embeddings, so I don't want to go into the detail here, but just to lay out the land, at Uncode, we calculate our embeddings using a clip model. We embed both the images and the objects and the model predictions. And this enables you to then conduct similarity search, natural language search, diversity sampling, and a lot of other things that are useful in your cleaning and curation process. We also reduce the embeddings with a UMAP reduction and then project it in 2D to allow you to interact with the embeddings, something Alex will also get on to in the demo in a bit. If you're interested in exploring fine-tuning your embeddings or potentially importing custom embeddings, please do get in touch. This is something that we're actively exploring right now and are opening up for in a beta very, very soon. Wait, let's quickly cover these methods one at a time. Firstly, we have cleaning processes. So here we can now use a quality metric-based technique. Here we use quality metrics to filter, search, and sort out all the messy data to find and exclude it. This could be images that are irrelevant, misleading, too blurry, too dark, or duplicates. We can also use an embeddings-based technique. So here we can find samples that are significantly different from a training data distribution. And we can also find it to use it to remove any outliers in terms of duplicates in the data set. For the curation process, we have 2 different flows as well. So we have an embeddings-assisted technique to identify sparse regions in your data set and help you curate a diverse data set. And then on the model-assisted side of things, you can implement this if you have a trained model already. So you can use your own model to identify areas that your model is struggling with and then curate similar samples. Or if you want to go down a more advanced route, you can sample your data based on different acquisition functions, such as proximity to the decision border or least confident. For the enrichment phase, we can use similarity search in combination with bulk classification to semi-automate the entire image classification process. And for more advanced users, you can import your model predictions as pre-labels. A tip here, if you don't have a trained model, would also be that you can use a foundation model combo. So you could, for example, combine SAM with Grinding Dino to get pre-labels for your objects or segmentations. If you have a classification or an image captioning problem, we'll recommend using Lava or GPT-4v, something that we've also been experimenting with at Uncode. To give you an example here, we see the natural language search, where we conduct a quick search query for keywords, select the images, add them to a collection, so a group of images, and then bulk classify the entire collection as seen here. Next up is model-assisted labeling. We can see here on the panoptic segmentation example, so this is to our right, that not all of the model predictions for this panoptic segmentation are perfectly annotated by the model, but it's a far better starting point for annotators than a blank image. So for this example, all the annotator has to do is to clean up the fries, there's a chicken box here and the carton around it, and then the label is turned into a ground truth. Similar methods can be applied for classification or image captioning. So in this example, we gave Llama a bunch of images and a predefined prompt to describe the image in detail, whereafter our team of annotators, they corrected and expanded upon the caption. Lastly, for prioritization. So you can prioritize your data before you send it to annotation team, either using a manual approach where you can prioritize one image or sample at a time, or using a semi-automated process where you run your images or videos over a diversity-based acquisition function, and then you adjust the priority according to that. So you rank the most diverse images first, and those are just the ones that will be surfaced for your annotation team first. Good. That was all for me. Now I'll hand the screen over to Alex to take us into today's demo.
Thank you, Nico. I will share my screen. Nice to meet you all. As Nico introduced me, I'm Alex, so lead the ML solutions team, and I'll be giving today's demo. Great. So what we're looking at here is the data cleaning and curation tool that Nico was talking about as he was setting the scene for us and this demo. So the data we're going to be looking at today is art data. So we've sourced an open source art image data set. So you can see there around 41,000 images in this data set. And we're going to want to train a model that's going to be able to classify various kinds of art. So we need to make sure that we curate our data, find potential labeling errors, corruptions, the ones that Nico was talking about, and then prioritize the data according to the actual end objective, right, which is just to recognize different types of art. So in this case, we've imported this data into one of our S3 buckets. So we're sitting directly on top of the data storage. And this is allowing us to make sure that we can clean up this potential landfill of data storage, as Nico called it, where we might have various data assets that have come into the mix that are not relevant. First thing I'll show before getting started with the demo is the fact that we also have the annotation view, which is this view here. So this is where we will have the annotators going into either correct pre-classifications that we might apply in bulk on the tool, as Nico showed, and also prioritizing the right items for labeling. Currently, nothing has been prioritized. Everything has the default priority of 50. We'll see this changing throughout the course of the demo as we structure and curate our data. So going back to our data curation and cleaning view, we're going to start to use the various tools at our disposal to structure and scalably curate this completely unlabeled data set. That's one thing I want to absolutely draw attention to, is the fact that this data set has not been pre-labeled. So everything that we're doing here, all the insights we're gathering, are purely derived from the tooling available to us here in the cleaning and curation interface. We're going to start off simple, some of the simpler tooling at our disposal, and start stacking and combining these and increasing the complexity of the tooling we're using to structure this data set. So the first way we can get a general feel for our data, do this piece of general exploration before we start to move on to corrupt data detection and metrics-based filtering, is to look at the embeddings. It tends to be a very clear and natural way for people to get a sense of their data set. Where are the clusters? Where are potential outliers? How can we explore them through this sort of easy and clear interface? So we can immediately see here a few islands that are coming up. So I can go ahead and just easily filter on those to see what's going on. In this case, we can see that these are outdoor photographs of mainly castles and houses, but also what seems to be someone's coffee that they were having potentially whilst doing this photography shoot. So we're going to go ahead and start tagging these. So we can, of course, just continue exploring, right? Use the embeddings, look at these different areas, but it's good if we actually do something about them and we capture the results of our exploration as we go through the tool. So here you can see I can go ahead and select, say, all the visible assets here. So these are some the images of castles that I'm not interested in. and I can add them to what we call a collection. So Nico introduced this concept of collections. Some people refer to these as, sort of sets, or they can be views or slices over the data set. We call them collections, and this is how we're able to start organizing the data in the data curation tool. Call this outdoor photographs, and add these images to a collection. As we build these collections, we'll note that these are not necessarily mutually exclusive collections. We can put one image in multiple collections, and we can also start to use them later on to edit what we're looking at. So start excluding them from our view. You can see here that we have our first collection that we've created, outdoor photographs, and we'll add to this list as we continue exploring the data. So I'm going to go back to the embeddings plot, look at a few other interesting areas. So potentially here we can go on this embedding here, this region here. And here we find some vases and also necklaces. Again, we're potentially not interested in these, so we can go ahead and select this entire page and add it to our collection, a new collection, which is going to be a vase collection. Fantastic. So you can see now we're starting to build these right as we explore the embeddings, and we're going to be able to use them later on. The last piece of exploration we'll do directly here in the embeddings view is to look at this cluster down here. Now we can see when we do this that this looks like Japanese art. We've sourced this from quite a diverse data set where we have lots of different kinds of art, or at least that's what the dataset maintainers say on the tin. It might not be true, but we know that there's already some diversity there because we were looking at things like photographs, vases, etc. One of the types of art that we are interested in identifying, having our model be able to identify, is this kind of Japanese art. So I'm going to select, again, the ones in view, add them to my collection, and say Japanese art. So now we have this collection. We've got 3 collections that we've created. We can actually use them to do something interesting. So I can go here to my Japanese art, and you can see that when I select this collection, these buttons come alive. First action that we'll take a look at from this curation and filtering example is the ability to bulk classify, right? So we might have identified through the embeddings, potentially through other methods that we'll see later, something interesting about this scene that is going to help us in the labeling process. In this case, we actually can answer just the question of what class of art is this, because we saw them in bulk and we found a clear embedding region there. And you can see these are all the scars of art we're going to try and classify. This was defined as our labeling protocol. We want to classify these as being a specific kind of art. So I can go ahead and select my Japanese art here. You can see we have the explanation of what this is going to do, but essentially it's going to apply that label to the data assets so that we can simplify the problem of looking at something and trying to understand what it is, potentially in a sequence that doesn't necessarily make sense, to something that's pre-labeled where we just have to verify what's been done. So you can see there I started the bulk classification, and that's now been complete. We can now see that these data assets will be pre-labeled with the appropriate classification. I can open this up and I can jump directly into the view where we can see the actual data asset. And you can see here that we've applied this classification here as being Japanese art. This was not present before, but through that bulk classification process, we've added this. And the task now is simply to verify that this is correct. Fantastic. So now we've got a general sense for our data set. We've also applied some pre-labels to sped up the annotation and data generation process. We can actually start to look for potential errors in our data set. So these notorious corruptions that Nico introduced to us in his presentation. You can see on the right-hand side here that some issues have been found in our data set. And the most obvious one here are duplicates. Now, I'm not seeing any duplicates in this view. it's 41,000 images. I would have to, sort them by some metric, try and look through them. That might be difficult, especially without this tooling. I'd just be looking at my local file system or trying to, cook up some functions in a Jupyter notebook to filter through these. What I can do here is just click on that duplicates button, and you can see now that those duplicates are immediately surfaced, and they're very obvious in this particular view. You can see all of these duplicates here that are present in our data set. Now we want to make sure we don't waste, time and money having people annotate these, because if we're working with a large team, right, they might get, two different people might get a duplicate, so they won't realize it's a duplicate. But either way, that processing time of having to look at these duplicates is going to cost us time and money. They will also not add to the performance of the model because we've just double labeled something. So we're not getting any benefits from having more data labeled. It's the same thing. It's been labeled twice. So I'm going to add these. I can add these to a collection. I can also change the way that I filter here, so I can select everything that's visible or select everything in here to start building up these collections. So I'm just going to pop this in as duplicates. Great. So I'm going to reset my filters. And now we're going to tackle a slightly more complex case. So you saw there, just duplicates, they were picked up for us by the tool automatically. We're now going to start looking at some of these other situations. So for example, darkness. Some of our images seem to be too dark and are being flagged here as having potential issues. So you can see I've hit darkness here. And we have a mix. So we can see here we have a mix of art that seems reasonable. It's just very dark. Maybe it's a specific style that was going on at the time. But we also have these black squares with no data, or as you can potentially make out, you can see some of them we can see some sort of outline here. So maybe when this was captured, it was of poor quality, or there's another kind of corruption going on. If I go on to filter, you can see that darkness is pre-filtered, right? So it's gone on the brightness metric. So this is a metric that Nico introduced. It's a derived value from all the images that we've brought in, and it's being used to make these kinds of analyses where we can find areas of interest and potential issues. So I'm going to bring this slider down even more just to get out the sort of tail here. And now we're really seeing more dark images dominating this that clearly look like mistakes to me. But we still have, for example, what seems like quite a legitimate image, this necklace here, that we need to potentially remove, right? It's not actually an error. We don't want to include it in our selection of errors. So I can go ahead and combine this brightness filter with a contrast filter. So we're going to remove the high contrast images because those seem genuine and just target these low brightness, low contrast situations. So you can see here as I go down, we're excluding the higher contrast ones. And now we have a really great selection of images that are not relevant images. So you can see we're going through all of this, and all of these ones here at the top are not relevant images. So we can go ahead and add all of this to our selection again. So you can see as we're doing this, we start to build up these collections and the things that we're going to want to exclude, right, and give low priorities to in the labeling process. Great. So this is a fantastic segue into metrics. So we're looking, at the pre-built filters, but then also combining them with other filters in the tool. And it's going to allow us to set scene for using more filters here. So I've noticed here that there are some images that seem to be chopped. So you can see here we don't have, I'm assuming here that there is a sort of bigger piece of art than just the sort of middle section of this person's chin. So we're going to go and see if we can find a relevant metric to tackle this particular error mode. So I'm going to look at aspect ratio, and you can see that we have some sort of aspect ratio down here. But if we look at this one, it clearly has a very high aspect ratio. So we're going to start to change our filters here. Now, I've increased the lower bound here of the aspect ratio filter to somewhere that, where we can clearly see these kinds of errors. But we need to try and understand before we potentially take all of this and put it into a collection of, chopped images, whether this is reasonable. We can see that this filter extends all the way to the top, and we've only set the lower bound and not the upper bound. So I'm also now going to sort by this aspect ratio, and I'm going to look at both ascending and descending. So now we're looking at the lower end, right? So we have our lower bound, looking at the lower end sorted ascendingly, and we can see that there are still some very legitimate images in here that we would not want to exclude. So I can increase this, continue increasing it until I'm going to find images that are clearly problematic. See here, keep going. Okay, and now we're starting to see some of these chopped images that are not just, high aspect ratio pieces of art, but rather genuinely chopped images. We're going to do the same thing descendingly. So now looking at the top end, again, some extremely high aspect ratio images, 6.1 here, which are legitimate. So we're again going to bring that down until we only have the range that is clearly affected by this chopping problem. Great, so it looks like here, we basically have everything we need below 4.5. So I'm going to actually now add this as a filter so we can use it in future to detect similar kinds of issues. So you can see here, I've got my presets. I can create a preset and I can say chopped images. And this is going to be really powerful because it means that as we continue streaming data into our bucket, as we continue refreshing this project, we move on to another similar project that's going to have data, let's say, from a different museum or such like. We're going to be able to reuse these kinds of presets. So you can see here, I can load my presets. Here are ones that we've done in the past, things like our distribution images, these high OU chopped images, etc. And we can reuse them in further analyses as we grow our data set right to very large levels to tackle these error modes that we've identified in the data kind of sourcing process. Right. So what we're going to do now is use another tool in our arsenal of data curation, and that is similarity search. So Nico mentioned, that you could use all these different tools, the embeddings, expiration, the quality metrics, but also things like similarity search and natural language search. So we'll look at those now. And you can see that we're building, we're taking different tools from our arsenal to tackle these different types of errors. So finding things, in a very, strict way with the quality metrics, finding things in a slightly more exploratory way with the embeddings and the similarity search. So let's say there's a type of art that we recognize immediately and that we want to find more of. So you can see something that could be interesting here. You can see here we have this scene with some people on horseback and there are trees. It's quite a nice scene. This is, as I've recently learned, some Renaissance art. So I can hit this button here to trigger a similarity search, and this will take this image and place it as a reference image. We can then see lots of other pieces of art that are also Renaissance art. Again, this is going to help us do something, right? We're not just curating our data for fun. We're curating it, or we could be, but we're curating it in order to speed up the time to value, right? And reduce the labor of labeling. So you can see here, we've selected everything that's visible. We're going to add it to a collection, and we're going to call this our Renaissance art. And what we're going to do is we're going to use, again, which here, but we would do in a production setting is, again, do what we did for the Japanese art and pre-label this as a Renaissance art scene. The last way that we'll show penultimate way that we'll show how to curate your data here is the natural language search. So we noticed in our photograph example that there were some castles. We haven't labeled any castles, we just found a cluster of castles. But what we can do is we can actually just look for castles, right? So in those outdoor photography scenes, there were castles, but other things as well. I think there was someone's coffee actually included. We can just look for castles here and we will find castle imagery. So you can see this includes both drawings of castles and images of castles. We can go ahead and try and look for example, real castles. As you can see now, we actually get more photographs of castles rather than drawings of castles. We still get some drawings, they're just ranked lower in this view. Great. The last thing that I'll do is in the natural language search part of things is look to castles. We've already seen some castles. Maybe we saw that image of the coffee, and we think there could be someone's holiday snaps could have crept into this data set. This S3 bucket might have someone's holiday pictures, or at least irrelevant pictures here. Now, some people like to do different things on holiday, but one thing they might like to do is play football. So we can spell football correctly with 2 L's, and we can find these situations here where there is actually some football going on, and so we can do a similarity search on these football scenes, and now you can see that we find again kind of irrelevant art. This is not really art, could be, but in this case, this is not the art we're interested in. We're interested in classical museum art, and so we're going to tag this as being something that we're not interested in putting it into our collection. As we do this, it's going to allow us to really structure the dataset, clean the dataset, and make sure that we're only tackling things that are relevant. Irrelevant images. So, we've looked at the natural language search. We're going to go back to the embeddings and see if there's anything else that we can find. So we saw those, isolated clusters. We didn't explore all of them. So we're going to explore a few more and see if we can find anything of interest. See here, if we go ahead and look potentially here, what do we have? Just have some images of, sort of warlike art. I'm going to look over here. And now we found something interesting, which we actually already saw when we were looking for football images, which is these situations with some green lines on them. And this could have happened, at capture time, could have happened, in a sort of a real-time streaming situation where the images were poorly saved or transmitted. And so we're having these situations that are undesirable to us. We can now select one, so let's say this one, use it as an anchor for our similarity search, and then we're going to actually reset the filter over the embeddings that preserve the similarity search anchor. So this is really useful for finding something with some filters. We could have found this with another combination of filters, perhaps greenness would have showed this well, but then we can select that one and then remove all those filters and use a ranking approach to find the relevant pieces. And that's to ensure that we don't, our filters, especially a complex combination of filters, could have missed out the full filter space that identifies these kinds of errors. So we can exclude all of these corrupt images. So I can go in here. You can see I've selected everything here. Select all the visible ones if I just want to refine to what I'm absolutely sure is something I've seen that's relevant. So I can say these are corrupt. And then to my collection. So the last thing we'll do now is, we've explored data, we found failure modes, we bulk classified and started building up these collections, is that we're going to actually prioritize something for labeling. So you can see here, if I go to my filter, I can add a filter. I'm going to filter by collection. I'm going to exclude the collections that I'm not interested in. So all the ones that I identified here, except for Japanese art, are situations that I'm not interested in. And I'm now going to use the diversity acquisition function to select the relevant dataset size that I need. So let's say that we had these 40,000 images. We're going to filter down to something that we have a budget for, and also that is going to allow us to go fast. It's not just about saving the budget, but also about time to value, right? The faster we annotate a diverse set of relevant images that are not corrupt, not duplicates, sorts of things, the faster we can actually get to a first version of our model, see where it falls down, again using the same tooling, which we unfortunately don't have time to go into today, but we'll see in a future session, and then we can iterate on that. Iteration solves all problems. So we can filter this down. We can look at the most diverse images. So now we have 5,000, and these are the ones that we're going to want to prioritize for labeling. So I can say these are my high priority images. I can go into my collections here, and you can see now that my high priority images, so these 5,000 that I selected, are available to me. Going back to my annotation view, just quickly, you can still see everything here has a priority of 50. What we're going to do is we're going to increase the priority of these. So we're going to say this 5,000 is what we want to label first. It's the most relevant, it's the cleanest. It's what's going to help us build a model quickly and efficiently. We can also separately, if we've identified interesting things, leave comments on the tasks to help guide the annotators to look at specific things. So you can see there, I've put this in, and this will increase the priority of my tasks. I can also do the same things with things that are relevant. So these are relevant images. I can set to annotate and send them in with a 0 priority. So I can go in here, sort of ascendingly, and you can see here that these have a priority of 0. So they will be fed to the annotators last. In this case, we're going to make a rule saying that priority 0 means, a tombstone, something we're not interested in. Similar thing will happen for the prioritization. We'll prioritize those 5,000 images for annotators to tackle first. Great, so that brings us to the end of my demo. We've covered many things in this demo off the back of Nico's setup and explanation. We've tackled the points that he identified as things that our customers are having issues with, that we've helped them with, and that we see in the market. So around the whole angle of being able to find data errors, exclude data from these large data landfills, as Nico called them, where we have data that is not relevant to us and it's going to hurt the model training process, but then also do good things and find positive things, interesting things that we want to pre-label to speed up the labeling flow and adjust the task priority in order to feed the annotation queue optimally and get to a working model as quickly as possible. Fantastic. Nico, I will hand back to you. I'll stop presenting, and I think we've got some questions that we can tackle and some wrap-up slides.
Thank you, Alex. 1 second, then I'll put my screen up here. Gotcha. Can you see it again, Alex? Super. So we will first go through the pre-submitted questions before getting to the live questions that came in from some of you. For the questions that was pre-shared, first one here, is there an active learning guideline in the wild that says which active learning to apply and which sampling strategies work best for a given data set and so on? This is an excellent question. Thank you for sharing that up front. So based on our experience, there's no acquisition function or strategy that fits all. I know that's an annoying answer here, but we know that if you have below 5,000 to 10,000 images, don't bother setting up a full active learning flow. Then rather wait until you have a larger data volume, because the setup cost of getting this set up can be cumbersome in some cases. If you're looking at academic research, then the two most prevalent acquisition functions here for your active learning is the diversity metric that Alex showed before, and least confidence as well, which is something that you can do with your model predictions. So in this case, you would import your model predictions into a tooling such as the one Alex showed, and rank them based on the confidence of the model predictions. Be mindful though that some of these research projects, they were mostly conducted on open source datasets, Coco and ImageNet, so they might not transfer as well to real life scenarios. The one that we normally see our customers use is least confidence in this case. Then the second question, how do you know what data is enough to train deep learning models on? Alex, maybe this is one for you.
Sure. Thanks, Nico. So again, slightly frustrating answer, which is it depends, right? But the main thing about this question is that it's asking about scale, right? Like how much data is enough. Of course, it's going to depend on the model, for sure, and the exact use case. But the way that what we've just shown in this demo and what I like to prioritize is what is the most relevant and the best data out of my data set to train the model. Of course, scale matters. More data you're going to label, the better your model is going to perform. But depending on how you feed the model data, if you say I'm going to take the first 5% and they are duplicates, they're corrupt, and they're not diverse and not representative of the whole problem, then your model is going to learn worse than if you potentially had selected less data, but it was, clean and it was diverse and it was, adapted to the learning objectives of the model.
Gotcha. Thank you, Alex. And next up here, what are some new tools and techniques that are upcoming in your roadmap? It's a good question again. I think I can share a little bit here, so lift the curtain on some of the things that we're developing for the coming months. So currently our team is investigating 2 new tools. I brought a sneak peek here with us today that we can show. So first one is something that we call auto failure clustering. This is something that would take your model predictions and correlate it with your different quality metrics and with the embeddings in your project. We can also correlate it with the different annotators or with the classes to figure out what are the common failure clusters in your data set. So this will be the clusters where your model performance is significantly lower than the baseline. So in this case, you see here from our beta version, you'd see that precision is 30% lower when model confidence is low and the relative area is small. So in those cases, we would highlight this cluster for you as something you could take a look at, either for labeling or relabeling. Furthermore, you see here on the lower one that the average true positive count, also a percentage, is very low if the aspect ratio is high and if a specific annotator here from the linear probes has annotated the image. So there's a lot of interesting ways that we're looking at combining and correlating these different metrics with your model performance. Another one that we're looking at active learning smart sampling. So instead of conducting active learning manually or semi-automatic, as Alex showed before, we want to set it up so it's fully automatic. So in this case, you will be able to create what we call a smart collection job, where you select your acquisition function, your model predictions, your class balance, and then automatically you will get a fully curated data set based on that strategy. And this then becomes super powerful when you stream your data in from your cloud bucket, because your data set would automatically be filtered based on your preset filter and then curated for annotation. So again, our goal here is to set up as close to an automated pipeline for you as possible. I hope that answers your question on your upcoming tools and roadmap. Feel free also to reach out afterwards if you have any specific questions that you'd like to hear more about. Next up, is there any way to manage my data set with pre-labeled data? Alex, maybe one for you.
Yes, thank you, Nico. So we didn't get time to dig into the labels tab. That's going for a future session. There's a lot of richness and power there. But using the SDK, you can pre-label your data. So pre-classify it. You can also pre-segment it if you have segmentation models. Whatever the task it is that you're trying to achieve, you can pre-label this, and then you can use the active tooling, which is going to sit on top of all your data to manage it based on these quantitative metrics, similar to the ones that we talked about for the raw data curation, but actually targeted and specialized to the annotation and label domain.
Gotcha. That's a good one, Alex. And then lastly, what ways can I filter my data set? And can I use some form of natural language search? This was clearly sent in before. I think we covered most of this in the demo previously. There are very few limitations to our filtering options. So as you saw before, we support filtering on these 40 pre-computed metrics. And if you have any of your own image properties or object properties that you're interested in, we support custom metrics. There is both a simple recipe for writing these custom metrics yourself, or if you have any ideas, then you can always reach out to us and then we will take a look at it and help build this custom metric. For the natural language search, yes, as we showed during the demo, it's based on clip embeddings. We're looking at supporting both fine-tuned embeddings and custom embeddings for the natural language search as well. So if you have any specific use case in mind here, please do reach out. Then I got a question here on how many filters I can combine. Maybe Alex, you can take this one.
Yes, so we showed the natural language search there. So it's something that is absolutely available. Natural language search can be very powerful and works actually remarkably well even across use cases that can be a bit more niche. So it's a very kind of clean and intuitive way to interact with a data set, start exploring it.
Thank you. Then we have a few questions here whether the session is being recorded and we're sharing slides. Yes, we can potentially share the slides afterwards, and the recording of the session will be available on our blog either tomorrow or later this week. And then the last question of today here, are we covering products such as e-commerce products? And if we are, how do we match certain products together? So let's say that we have two data sets and we want to match all the toasters in both data sets. Could it be here that we have a train a model on recognizing what a toaster is, or is there other clever ways of matching these two? Brilliant question as well. I would love to discuss that use case more in depth afterwards. I think the primary way I will go about this is two approaches. One would be to use the similarity approach that we use, so either the similarity search or the duplicate metric to match the two data sets. So you can easily attach two data sets to the same project. So project is what Alex showed before. And then secondly, what we could also look at is to train a very simple classifier. Given this would be e-commerce products, it wouldn't be a hard classifier to train that could then figure out which images are toasters, which images are microwaves, ovens, and so on and so forth, and then neatly put those into collections. And then, of course, what you want to do with those downstream, we can chat about that offline. Super. That brings us to the end with 2 minutes left. Thank you, everyone, for listening. It's been a pleasure hosting you here today. Thank you, Alex, for coming along and helping. Here are our next webinar happening in a month's time, where Frederick, our lead machine learning engineer, will be talking about visual language models empowering the next chapter in AI. So if you want to sign up for that already, I'll leave a QR code here, and this will also be available on our website very soon. Thank you very much, and have a great day.
Thank you, everyone.